Hi, welcome to the video tutorial for another data handling lesson that's called Jimmy's Story or Jimmy and the Newspaper. And in this lesson you put the children in a situation where they explore a hypothesis that's not correct and start thinking about other ways of interrogating data. So you're doing some really quite interesting things with the pupils that I didn't really do till I didn't really understand. I did my degree at university, the importance of a hypothesis. A good hypothesis is key, a good question to interrogate. Even in my own research, it took me ages to come up with the right question. Then you've got to design something, and often that changes. So there's some really interesting messages in this lesson, such as how important a hypothesis is, how important good design is to test a hypothesis. How do you handle data? You could have this lesson where you don't give them a tally chart, you let them think, how am I going to handle the data? What am I going to do with this data to make sense of it? Everything the pupils normally get is formulated, is the tables are given to them, and they're never allowed to explore and think, is this a good way of handling the data? So you could make this very, very open. Read the notes because it's very interesting. There's a part at the end that I very rarely get to, because the steps you take the pupils through and where you can link is really quite interesting. So this lesson starts with a story of two children reading. Well, it's a boy reading with his cousin, usually my children, and the older sibling comes in. So Samuel and Ruby were reading this book. And Flora, the eldest, comes in and says, Samuel, read that book, that's a big boy's book. And of course, chaos breaks, they have a little fight and there's tears. And Samuel says, but Uncle Alan, I'm a big boy, I read big books. And Ruby says, it's all right, Samuel, that is a big boy's book. So you say to the children, is there anything in this? Is there any difference between the two books? Okay. Do you think there is a difference? Do you think this one's harder than this one? And what might make it harder? So you're raising those questions in the minds of the children. And what you actually present them with in this lesson is two samples. A sample of text from The Guardian, or a high-quality newspaper, and a book by Leela Burke. I had a copy, but I left it in school, called Jimmy's Story. So you've got a piece of text from a book for 6-year-olds, and a Guardian. So the question is there any difference between the two books? And you'll say, well, what about Samuel? He's worried. He's thinking that older books have hard words in them. And you say, what does he mean by harder words? And you're trying to give them the assumption that we could explore length. So someone will say, give me a hard word, and the child will write some very, very long word like that they might have picked up from a subject. So this is a hard word, and the assumption is it's long. And you say, give me an easy word, and they'll say, was. And the assumption of that is it's short. So now you've got your hypothesis that some books that are harder might have longer words in them than easier books. So you say to the children, who agrees with that? Have a bit of a vote. And usually the majority of the class, there's something intuitive about that harder books, harder texts have longer words than the Jimmy Story. So what you say to people is, okay, I'm going to give you Jimmy's Story. I want you to sample the first 20 words. So you could either do the tally chart that's included in the results, or let them do it themselves. But what you get is you get this. This is the distribution of Jimmy's Story. Now, one of the messages in this lesson is how important spread is, the distribution of data, and that can give meaning. And actually, for a lot of children, they don't realise that a visual representation and seeing data is actually quite helpful rather than just looking at it numerically. They don't trust their eyes, they want an answer rather than just seeing something in it. So there's a chance to actually explore what this means. You could talk about the range. It goes from 2 to 8, so the range is 6. they say, oh, that's the most common. Sorry about that interruption. So, the children, often they've not been asked to talk about what they see before. They often say, what's this, what's that, what's that. Don't do that. Give them the chance to see things. And so, this is about, there's something intuitive and very visual in this lesson, that the children think one answer but realise it can't be right. So, we'll say, well, this is the most common, that's the mode. So the most common is 7. And then what you could even do is kind of do that. To get them to think about distribution, and for some bimodal distributions. I mean, I think children need experience of seeing data and understanding complexity from a very young age. The answer isn't as important as how they're seeing and what they're interpreting. So once you've done this, you can then say to them, okay, we're going to do the Guardian now. Let's make some predictions about the range of the Guardian. And they might say, oh, the range is going to be much bigger. So they'll say the Guardian, the range, I think the range will be 10. And you say, okay, what about the mode? And usually what they do is they predict that the mode is going to be somewhere here, much bigger than the mode of Jimmy's story. So what you then do is you then give them a page from the Guardian, each pair, and you say to them, okay, sample 20 words. I mean, this whole lesson is wrong. The sampling bias, they're not comparing like with like. You're dealing with one page from here, multiple pages from there. Everyone's doing the same. Everyone's doing different in the Guardian, and that leads to some really interesting discussions. But what's really interesting is, quite quickly in this lesson, the majority of people sampling the Guardian will get to the situation where the mode is 3. And you can stand back, actually stand back and say to them, hey, we thought it was going to be here, because it's a Guardian, it's not a book for 6-year-olds. We thought it was going to be here, but the mode's here. What's that about? And actually, because what is lovely is when they share their distributions, and the distribution is something like that. And you go, hey, that doesn't look right. What's going on here? Who can explain it? And often what they'll do is, they'll think there's something wrong. They'll think it's the problem with the Guardian. They don't, because there's a bias here. They think, oh, it's a problem here. They'll say, I had the sports pages, and you don't need to be clever to read the sports pages. They say all sorts of strange things. And you say, hang on, this can't be right. This is for the Guardian. That's for 6-year-olds. And some of them will look again at Jimmy's story and realise, and you can't tell them this, it's best if they discover it, and tell them that, hang on, children, Tracy, Robert, Susan, there's loads of names. And the idea is that, hang on, is that right? Is it right that there's lots of long words that are easy, that are names at the start? And then they start to realise that, hang on, there's something wrong here. We've sampled a bit that's biased, that's wrong. So, I mean, that discussion is very, very rich when they start sharing it, and then they start thinking, actually, there are other ways of comparing books. So what you ask them to do is then sample another 20 words of Jimmy's story, and what you end up with when you sample another 20 words of Jimmy's story is you end up with distributions that are very, very similar. That the mode is 3, the range might be different. So they start realising that our hypothesis was wrong. We never give them, there's a lot of activity in lots of activity in a similar science project where we make them realise that there is no relationship. And life is full of situations like that. Politicians want certainty. They've got to be certain, it's got to be this, it's got to be that. No, you will never get 100% certainty. Often there is not a relationship. I mean, the key thing was 18, 20 years ago was the MMR vaccination debacle, where someone took a sample of 6 children and scared the whole country. and said there's a link between autism and bowel disease and MMR vaccination, a tiny sample. And there are loads of examples you can now share with pupils where so the whole scenario is we had a hypothesis that was wrong, but we changed our sample and actually the answer changed. So there's loads of examples of bridging or reflecting on it. Have you come across situations where if we redid the sample, might the results be different? I mean, the whole thing at the moment is the debate on leaving the European Union. What if we did it again? What about sampling polling? I mean, that's been discredited because what samples are they taking to find out how people are voting? Where is sampling really, really important? So I think there's hundreds of examples you can use to pack out that are current and relevant. But what's interesting is there's a last part to the lesson where you start to encourage the pupils to interrogate and look at different samples. We do not want students to be fixed in the way that they explore data, average, or mean. We want to get them to look at other samples of data. So in the resources, there are 3 different samples of text from 3 different news sources. And you can then analyse them in different ways. You could get them to sample the first 20, the middle 20, the last 20, the whole sample, look at the mode, look at the range, look at others. And I mean, you can even use Word to explore grammar. There's features on there where you can explore text. But it's a very, very interesting lesson, but it's a classic thinking math lesson in that you set them up for a fall and then they realise and they look again at the data and they change their mind and you can bridge that to their own examples, and I'm sure you'll really, really enjoy it and adapt it and link it to things that you think are important in terms of sampling and coming up with a good hypothesis and good experimental design.